Kia ora koutou, ko Kirsty Mills tōku ingoa, no kirikiri rawa aho. I'm coming at you as our last solutions consultant and final presenter for our webinar today as a previous science and chemistry teacher to show you the new science lessons. So we have a small first release, which is our first offering into the new science for year 11. So the new standards, but also just looking at ways that schools also not doing the new standards can also utilise these same lessons, ideas, and inclusion of new curriculum and the importance of weaving in Mātauranga Māori. So today I will be sharing the layout and where to find the new science folders and how we've arranged it, some new lessons within there and how we've weaved in Mātauranga Māori and mana orete o te Mātauranga Māori. And I'll also give a sneak peek into an investigation in these new science standards. So I'll be talking a little bit about the new standards, Science 1.1 to 1.4, a little about the Chem and Bio standards, and a little about the Physics and Earth Space Science standards. But I'm not going to be too specific about them at the moment because we have some supporting documentation which will really outline how everything weaves and fits together. And I just want to give you, in my short amount of time I have today, a sneak peek. And then afterwards we'll circle back round and hopefully can tackle some more questions as they come up. But I'm going to head to my Education Perfect account. If you want to see big updates, look on this updates tool on the right here because we have things like maps and ways that our new lessons and themes integrate with the standards. And this will be one of the spaces where you will see this linked, as well as within our support, especially if you go to Get Support. I'm going to just type in science. And you get a whole bunch in there that all link to science, risk assess, writing chemical formula, science and the Common Core syllabus. So science and the New Zealand curriculum. So that might be the one that you're looking for. So you can go through and find our documentation and guides in there. So content library, this is what we actually all want to look at today. And science, which I've got pinned to the top, I'm going to be heading to and spending most of my time in the sample lessons, New Zealand Year 11. I'm going to cycle back to this, but first I said I wanted to mention the layout of the folder. So you'll see at the moment we still have the existing NCEA Level 1, 2 and 3. So NCEA Level 1 is the 2023 arrangement as these standards are still being actively used in schools and assessed. So this is not going to be touched this year. What we have to help you look ahead to next year, NZ Year 11 Science, new. Now we've gone with the idea of Year 11 Science because we know there is a balance of schools doing NCEA Level 1 standards and schools doing their own diploma, their own curriculum, sorry, not curriculum, but like way of assessing the curriculum and their own sort of program that isn't using the NCEA standards directly. So Year 11 Science, this follows the curriculum strands. So all of the New Zealand Curriculum Level 6, NCEA Level 1 and Year 11 Science now folds into the strands in a way that matches our NZC junior content and just sort of flows through to the next level. It allows you to pick out things that follow themes and ideas with an overarching communicating in science to cover a lot more things that fit in within nature of science and overarching skills, such as if you are doing research, data, reports, and referencing, you can find all of those communications in there. So if we take a quick look at some of this arrangement, you'll see that Living World, for example, is organized into subtopics. And these subtopics, you should see a lot of good overlap or what you'd expect to see if you're doing for Living World the Chem and Bio standards. We should be expecting to see microorganisms, genetics, cellular biology, but then also some ways of doing practical biology investigations if you're going to be doing an internal investigation or nature of science through a biology context. So similar with Material World, physical world, and planet Earth and beyond. Now, planet Earth and beyond, you'll notice immediately we've got one of our new themes in there. So we've got Maramataka. And one is highlighted as new, just to draw your attention that this is a new themed unit with 6 lessons on Maramataka in there, ready to go. And I'm actually going to hop out of these, and I'm going to go to these sample lessons, because these are 2 of the lessons in the short amount of time I wanted to go over as examples of our first release of new lessons. So I'm going to look at food preservation first. This lesson is a good way of showing what the new content is. Also, it sits within a bigger themed unit of rongoa and microorganisms. So we've got te miruai, which is our microorganisms, and in there we have rongoa, we have food preservation, we have function of microbes. So we've got a whole bunch of things which weave and link together to come across this whole overarching theme. So this lesson on food preservation, all of these lessons start the same. They have an introduction tackling what is the significant learning idea being explored, the inquiry practices, the inclusion of Tauranga Māori, and how it explores the natural world, and then a whakatauki and our sort of banner to bring that together. You'll have your learning objectives before getting into the information. So the information is quite broken down, where you've got the background knowledge written to that high level than you would have seen in the junior content, so the level expected for year 11. So a whole slide just on bacteria, definitions and modes of action, yeast, and molds. And so we'll be highlighting in this lesson, for example, the unique features of the cells that make up bacteria, yeast, and molds, and also how they are both harmful and beneficial, before heading into the conditions for microbial growth. So these will be things that lead to like ideal reproduction times, warmth, moisture, and nutrients, what those conditions are, because those will inform the practices in the inquiry and the investigation for food preservation, but also into other lessons on rongoa and on bacteria and microorganisms as well. So today's lesson comes with the focus of food preservation. So we're looking at how these main ideal conditions are vital in preventing food spoilage, ensuring safety. So it starts with the Māori methods of traditional preservation and safeguarding food: hangi, drying, and smoking. And then further into fermentation, so specific fermentation with piko and marinated ika, and then how that works. Refrigeration, storage and pits, so the rua, cool, dark, control of temperature and humidity for kumara pits, and then preservatives. So kawa is used as a sort of overarching natural example of flora where they're used for antimicrobial properties. So you'll see them in rongoa, and you'll also see them here in food preservation, in the investigation as well as the lesson. And so kawa is used as one of the examples of something that has the antimicrobial properties, so therefore it can be used to help wrap and preserve food. For any methods not covered by the Tauranga Māori, you have some other methods that come from more Western knowledge, so vacuum packing, aseptic, and microbial testing and quality control, so methods of detecting food spoilage. And then also looking at not only what are the methods, but why. What are the cultural traditions, and how does this practice allow for safeguarding biodiversity and sustainability? So here we have 6 categories of how these all interweave together. So if we're looking at the empowerment, whakamana, involving community and preserving traditions and passing down knowledge for cultural continuity. So this knowledge is not useful unless it's actually able to be passed along and empower others to involve it with the community and make it a cultural value to empower people to pass on this knowledge, so it's actually useful and can be utilized generation after generation. So few more in-depth ideas and links in there before going into, for students, application. So starting simpler and then heading into writing applications, where all of these have keywords and answers provided. And all of the lessons, if they have no further activities or information, they all end with glossaries, looking at the science, looking at the culture and the mātauranga, and then the anything else as well. And then evaluating how they've done with their learning as success criteria, and a final summary of all the information they learned, ending with the learning objectives, have they met them? So we'll see those same things again echoed in Maramataka. And rather than go through the entire lesson with this one, I just wanted to point out a couple of things. So you'll see the beginning looks the same, and then it goes into, for this Maramataka lesson, it looks at solar, lunar calendars and the variety in there as well, especially a lunisolar calendar, one that combines elements of both. Introduces the concepts of Ruhanui, so the rest month, Maramataka, what it is, and not just saying that it's a lunar calendar, but then also the whole practice as well. And the ideas of Matariki, Te Matahi o Te Tau, the Māori New Year, and it delves into orbits, the idea of the leap year, sort of the moon's orbit as well, and how the reflection of different amounts of light creates the different phases. But then going into Maramataka. So all the influences of why a lunar calendar is used and what this means for cultural practice, gravitational push and pull, the amount of light, the tides, all of those influences. And this is the part I wanted to get to. So in here, it has an interactive thing link where you can click on any phase of the moon and it will tell you what this practice looks like. So Ohua, the 14th day after the new moon, is a good day for planting, and it has good returns for seeds and seedlings. And so this will take into account the amount of light being reflected and visibility, the position and strength of tides, and it brings into underneath letting students know that Maramataka is a holistic understanding of the interconnectedness of nature. So it looks at the concept of good and bad days and what good and bad means in terms of practice. Is it a good day for planting or fishing? Is it a bad day for planting or fishing? Why? What natural phenomena are informing that understanding? So looking at phases of the moon, the natural rhythms that are influenced by that phase, and environmental factors. And this is where your ability to customize the Education Perfect lessons comes into usefulness, because we make notes quite often in key locations around these lessons that this is a cultural practice that varies among different Māori, hapu, and iwi. So when you see this note, this is a good way to integrate it back into what is local to your area and the ability to localize the lesson. So bringing in what is your local iwi's variations, interpretations, and applications of Maramataka. So are there particular eeling practices? Are there particular planting and harvesting practices that are done at different stages of the moon? Are there different practices that are carried out on the marae in the community based around this knowledge? And are there ones where you might, instead of just using this lesson as is, you might take your own edit by going add to my content at the top? You might make your own copy. And in this space down here, you instead may put in an extra link or extra resources, or you might add in a question or edit a question later on around the application of manamataka. So it might be getting students to look at one way that manamataka is uniquely implemented in the local hapu or local iwi, and why this may be different, like what difference and why this exists if known. So there's ways that you can really customize it to make it local and applicable as well. And then it goes into the usual expectation of recall and understanding, then looking at different calendars around the world. So the different types of lunar and lunisolar calendars. So knowing that while the Gregorian calendar may be a bit more solar based, there are other types of lunar calendars that exist around the world, and their understanding before going into application. So what is the difference between a lunar and solar calendar? And what is a lunisolar calendar? So looking at the difference between different calendars. So again, this might be one that you edit to look at something more customized towards what your curriculum application is trying to tackle, your program, before going into the glossary and evaluation at the end. Okay, so we're pretty low on time. So our last little bit we're going to look at today, I'm going to head back into the new Year 11 science. I'm going to head into microorganisms. So in folder number 4, microorganisms and disease, you can see there the new lesson Rongoa Māori, food preservation, new, we just saw that one earlier, and then underneath investigations. There's two types, kawakawa and piko piko. So I'm going to look at kawakawa for food preservation. And so this one here is, instead of being a lesson, actually gets you to investigate different methods for preventing food from spoiling, with a focus on traditional methods. So looking at what is kawakawa, what are the active compounds within kawakawa that make it an antimicrobial active compound, and then looking at the tikanga and protocols around using kawakawa. So it's a really good idea when doing these investigations to look at what are the best ways to harvest and the tikanga. So utilizing a proper karakia, and if you don't have a good karakia for harvesting kawakawa, then there is one provided as well that has been provided by our writer as a good one to use for anybody wanting to harvest and utilize kawakawa. Equipment lists, so making sure you've got these and you're able to put them into like risk assess and order any equipment that you need ahead of time. And then a method as well. The method has been purposely placed onto one slide, so you're actually able to print a paper copy of this slide or use a single slide there if you want, or have students put the entire method on one screen and not have to touch a screen while using equipment. And then before getting into what students are required to do in terms of their microscopic observation. So this is an observational investigation where they observe the microbial count on the food for, a control versus using kawakawa, and how to do a microbial count as well. And there are other things that students can do observationally. So it's a good way to teach them observational skills in terms of other senses, not just a count of amount of microbial growth, but also color, odor, all sorts of other things that can come in to do with the senses. Controls, variables, and then a suggested way of recording observations. This is a suggestion. So over 7 days, looking at your count of microbes on your food item wrapped in kawakawa versus unwrapped, or a control. And then you may also wish to have, instead, as well as a count, observations. So you may want to do observations of other senses for your wrapped and unwrapped. So it might be the change in color, the amount of odor, it might be the presence of visible growth or slime or anything like that. And then looking at processing that data afterwards. So it gives a breakdown in how to do that. before going into understanding what are they looking for, and then getting them to write about it afterwards as well. And then, just like others, a glossary and success criteria at the end of their investigation.